Assalamu alaikum. I'm GM Mohammad Apurvo, and today I'm going to talk about a paper called Recognizing of the English Language Using Context-Free Grammar with Pyform-Lang. So let's get started. So here we have the table of contents where we can see that there is an introduction, motivation, contribution, methodology, result, limitations, future work, and lastly a conclusion. So let's get started with the introduction. So, natural language processing is a research field that combines linguistics, computer science, artificial intelligence, and machine learning to enable computers to understand human languages. The goal of NLP is to develop computer systems that can process and comprehend the content of documents, including the nuances of language. So, in this paper, we have used the Python-Lang library, which is introduced as a valuable tool for implementing CFG and language recognition. Python-Lang provides functionalities of defining variables, terminals, and production rules of a CFG. The paper presents a custom English CFG for language recognition. The CFG is defined with parts of speech (POS) tags as constituents, and it has proven to be effective in recognizing syntactically accurate English sentences with an accuracy of 84.9%. The paper also lays out a detailed set of rules for lexical parsing of the English language to ensure reusability. Moving on, we have the motivation of this paper. So, the motivation of this paper is to utilize the Python library and context-free grammar, which is called CFG. This is done in order to create an English language recognizer. So, firstly, the paper focuses on the pre-processing and parsing of sentences to determine if they are valid in the English language. This approach allows machines to understand and process complex human languages, thereby advancing natural language processing (NLP) capabilities. The paper highlights the advantages of Python-Lang and its features, as well as provides a detailed set of rules constituents for the English language. The accuracy of this proposed approach is reported to be 84.9%, as I've discussed before. Then we are moving on to the contribution. The contribution is paper can be summarized in some of points. So the first point is that the paper demonstrates the usage of the Python library for English language recognition using CFG. It provides a practical application for beginners to understand parsing sentences using formal language concepts. The paper lays out a detailed set of rules for lexical parsing of the English language, ensuring reusability of the process followed. The paper presents a custom English CFG with parts of speech tags as constituents, which is implemented using the Python library. So the accuracy we have discussed is 84.9%, and the CFG is defined with a start symbol, terminals, and non-terminals. The paper highlights the advantages of the Python library over other libraries for text parsing. Python provides functions for working with regular expressions, indexed grammars, and finite state automata. It also includes closure property functionalities such as concatenation, union, and reversal of CHGs. Then comes the field of NLP, where it is emphasized as the important part of pre-processing and parsing statements in order to check for legitimate sentences. It discusses the use of automata theory and CFGs in NLP and demonstrates the applicability of these concepts for English language recognition. Moving on, we have the methodology. So, at first, we can see that Python-Lang has been introduced. So the paper introduces the Python-Lang library as a tool for implementing CFG for English language recognitions. It highlights the advantages of Python-Lang over other libraries and its features. Then the CFG has been defined, where the paper defines a custom CFG for English language recognition using Python-Lang. The CFG is defined with a start symbol, terminals and non-terminals, and productions. This allows for the parsing of sentences and checking their validity. Pre-processing and parsing here are also done, where we have discussed that it emphasizes the use of automata theory and CFG for this purpose. The tokenization of sentences and obtaining parts of speech tags are important steps in this process. Rule-based parsing. The paper describes the rule-based parsing approach used in the implementation. It explains how the post tags of each word in a sentence are used to determine the constituents of the sentence based on the CFG rules. And finally, we have the evaluation and results, where the paper presents the accuracy of the implemented CFG for English language recognition, which is reported to be 84.9%. The results highlight the effectiveness of PyFormLang and the defined CFG in parsing and recognizing English sentences. Then we have the results. So here I've attached a picture where we can see that a confusion matrix has been obtained upon evaluating the English language recognizer on the custom dataset. The paper demonstrates the usage of um, Performlang library for English language recognition using CFG. A custom CFG for the English language is presented with POS tags. This CFG is defined with the start symbol, terminals and non-terminals, as I have discussed before. The advantages of using this library over other libraries for text parsing are highlighted, and its features are and functionalities are discussed. The accuracy, which is 84.9%, is also mentioned in the results. And lastly, the document provides a set of rules for lexical parsing of the English language, ensuring reusability of the process. Then we have the limitations part. I'm sorry. So here we can see the complexity of CFG. So we know that contextual grammars can become quite complex, especially for languages with highly ambiguous and nuanced syntactic structures like English. Creating an accurate and comprehensive CFG for English requires careful consideration of all possible sentences, uh, which can be time consuming and prone to human error. Also, as the size of the CFG increases, the parsing process becomes computationally expensive and can lead to slower performance. Another limitation we can see is the lack of semantic analysis. While CFG and PyFormLang are effective in syntactic parsing and checking the grammatical correctness of sentences, they do not consider the semantic meaning of the sentences. Semantic analysis, which involves understanding the meaning and intent behind the language, is crucial for more advanced NLP tasks like sentiment analysis, question answering, and text summarization. Without incorporating semantic analysis, the CFG based approach may not be useful for applications that require deeper understanding of the language. So, we have seen that there are some limitations for this paper, and then we go on to the future works. So we can see that the authors have discussed that they have some future works for this research. So firstly, we can see that the improving of the accuracy of the English language recognizer has been mentioned. Although the current implementation has an accuracy of 84.9%, there is room for improvement. The researchers can explore techniques such as deep learning and statistical models to enhance the accuracy of the recognizer, extending the CFG for more complex sentences. The current CFG is designed to parse simple and complex sentences of the English language. However, there may be cases where the CFG fails to recognize certain sentence structures. Future work can involve expanding the CFG rules to handle a wider range of sentence patterns. Incorporating semantic analysis. The current parsing approach focuses solely on syntactic analysis and doesn't consider the semantic meaning of the sentences. Future work can involve integrating semantic analysis techniques into the English language recognizer to provide a more comprehensive understanding of the sentences. Lastly, we have the conclusion. Here, the conclusion of this paper states that the English language recognizer implemented using the PyForming library and a custom CFG has achieved an accuracy of 84.9, which is really high for parsing English sentences. The metrics used to evaluate the recognizer, such as accuracy score, precision score, recall score, and F1 score demonstrate the effectiveness of the CFG in recognizing syntactically accurate sentences. The paper also mentions the potential applications of perform lang in various fields of computer science and highlights the advantages of using CFGs for language recognition. So that's it for today. Thank you so much for watching this video. Allah Hafiz.